Data in its graphical representation is most understandable and informative. We can represent the data in three different graphical forms: bar graphs, histograms, and frequency polygons. We shall first discuss the bar graphs. A bar graph is a graphical representation of data using vertical bars. In bar graphs, the bar of uniform width are drawn with equal spacing on x-axis, which denotes the variables. On the y-axis, values of variables are shown. For example, in a class there are total 32 students, out of which 12 are generals, 8 are OBC, 10 are SC, and 2 are ST. Draw a bar graph for the data. To plot a bar graph, we first draw a horizontal line and a vertical line with same initial point. The horizontal line OX is the x-axis and vertical line OY is the y-axis. Taking 10 lines of the graph paper as two numbers. Mark the number 0 to 12 on the y-axis. Now bar up to height 12 numbers for generals. Similarly, bars for OBC, SC and ST are drawn of heights 8, 10 and 2 respectively by leaving 5 lines of graph between two bars. This represents a required bar graph. A histogram is a graphical representation of numerical data. In histogram, width of bar is important as area of rectangular bar denotes frequency. The rectangular bars in histogram are touching each other. That shows that the class intervals are continuous. For example, the following tables show the distribution of students according to marks obtained by them in maths test. Marks and frequency. Marks 10 to 20, frequency 3. Marks 20 to 30, frequency 9. Marks 30 to 40, frequency 17. Marks 40 to 50, frequency 12. Marks 50 to 60, frequency 9. To draw a histogram of a frequency table, we first represent the marks on the horizontal axis. We choose the scale as 10 lines of graph paper is equal to 10 marks and represent the marks on x-axis accordingly. We represent the number of students as the vertical axis. We choose the scale as 10 lines of graph paper is equal to 2 students and represent the marks accordingly on y-axis. We now draw rectangular bars of width equal to class size and length equal to frequency of corresponding class intervals. In this way, we obtain the histogram. Frequency polygon is the very useful way of graphical representation of data. We take a histogram that represents the marks obtained by students in a maths test of class 9. Mark the midpoints of the upper side of each rectangular bar and name as B, C, D, E and F. Join the midpoints of upper sides of consecutive bars of this histogram. To complete the polygon, we assume that there is a class interval before 10 to 20 and one after 50 to 60, and their midpoints are A and G respectively. Join AB and FG, then A, B, C, D, E, F, G is the required frequency polygon.